right, hello, and let's start off today's lesson with this new topic. What we're going to do is we're going to learn how to solve equations in exponential form. So let me just write the heading. So the title of this lesson will be Solving Equations. Again, let me silence my phone. All right, solving equations, and the objective, I'm going to type out the objective. That objective would be objective is to use logarithms to solve equations of the form. And the form that we're going to look at, let's change this to green. The form that we're going to look at is a to the power of x equal to b. Now, we already know how to solve this by using the log equivalent, right? We already know how to solve this using the log equivalent. We can just simply say that, oh, well, a to the x equal to b can be converted with logs by just simply writing log base a of b will give me x, and we can solve it like that. But there's another way to go about doing it, and we can do this because it gives you more options to solve problems. Okay, so let's start the notes and we can just go ahead and run into examples really quick. Okay, so consider a to the power of x equal to b, and I'll just call this equation number 1, where a is not equal to 1, a is greater than 0, and b is greater than 0. Okay, now to find x, we take logs to any base on both sides. So 1 becomes log, remember this is log to the base 10 when I just put LG by itself, log of a to the power of x is equal to log of b. And therefore that means that x log of a is going to be equal to log of b. That means x is going to be log of b divided by log of a. And that's that. You can just simply solve that and you get it. Now, there's another one that I want to talk about, and I'll write this in yellow, and it is called natural logs. Natural logs. It is when you have log to the base of e. And if you want to find out what e is, you will have to look at that. Research it yourself, right? Anyway, log to the base e of, let's say, a number a is just simply written as ln of a. Now, the reason I'm telling you research it and not what it is, it's because they never specified about it in the syllabus throughout the entirety of the logs topic. I'm just stating it here for you so that you know that log to the base of e is what ln is, right? So you can take lns on both sides, and quite frankly, sometimes I like to do lns on both sides as well, right? So like, for example, this one up here, I would usually say like ln a to the power of x is equal to ln b, and therefore that x ln a is equal to ln of b, and that x is equal to ln of b over ln of a. It doesn't matter which one you do, both of them is going to give you the same answer on your calculator. Why do I prefer to do this instead of this? I don't like writing g. I like writing ln instead. So that's why I say I prefer use natural logs. Okay, it's a preference thing. It works out the same way. They have the same law. Just remember, log to the base of e is natural logs. Okay, and you can do some research and find out more about e, and you'll be very surprised at what it is. Let's go about some examples and some quick examples, because again, this is not something too challenging as long as you understand how to use, well, you understand your log laws and you can solve them. So like, let's say they ask you to solve a question 2 to the power of x equal to 11. Now, as I said, you can use regular logs, the log equivalents for this index form, and be able to solve it. But let's use this method up here where we take logs on both sides and solve it, right? So I can say given 2 to the power of x equal to 11, and I'm just going to put this as 1 here, and I'm going to take logs. Well, I can take natural logs too, but taking taking logs both sides, 1 becomes log to the power of 2 to the power of x equal to log 11. Therefore, that means x log 2 equal log 11. X is equal to log 11 over log 2. Again, you can do this in lns as well. So you can write ln 2 to the power of x is equal to ln 11. And then you can say x would be equal to ln 11 over ln 2 when you just work this part here out. All right, it's the same steps. You're just replacing LG with ln. The benefit of this ln is when you have a problem that has e, right? When you have e to the power of x and you take lns here, right? If you take, well, let's say this, right? Let's say that is the exponential form that you have. If you have this and you take ln e to the power of x equal to ln b, right? Then x would be equal to ln b over ln e. But here's the thing that you forgot. You forgot that log of e, log to the base of e, is what ln is. So if I put e here, remember this is a law already that you were given, right? This is literally just 1. So when it is that you have e, that exponent there, that when you have that e, right? It is best to use lns because then you can just simply replace that with a 1 instead, and it makes the whole calculation so much easier. All right. Let's work this out. Oh my God, I rambled and I didn't finish my solution. Hold on. Delete this. Go back up. Right. So there we have x equal to log of 11 over log of 2. And I can take my calculator and you can see, look, there's ln right here. Let me just show the calculator on the screen properly. There's ln right here and there's log right here. So I can just simply say x is ln 11 over ln 2, and oh, look, it's calculated right there, approximately 3.459, whatever. So I can just put 3.5, right? So I can say that x is approximately equal to 3.5, right? And it has some numbers after it. With this here, you can just simply leave it like this most of the time, because when you finish it like that, you can get an exact, that is basically an exact value, and you can probably use that solution to simplify something easier later on. Okay, so most of the time you don't need to simplify it. Example 2. Let's solve 7 to the power of x minus 1 equal to 20, right? And with this one, we can say given that 7 to the power of x minus 1 is equal to 20, and let's call this equation 1, then taking, let's do natural logs this time. Natural logs both sides. 1 becomes ln of 7 to the power of x minus 1 equal to 20. Oh no, wait, I forgot my ln of 20. Right, and then I can simplify this with the laws that I have before. So x minus 1, close bracket around that, ln of 7 equal ln of 20. Then we can have x minus 1 is equal to ln of 20 over ln of 7. X would be equal to 1 plus ln of 20, scroll down, over ln of 7, right? And we can just simply put that in on the calculator and get our value for x. So let's see. We have 1 plus ln of 20 over, you know what, fraction. 1 plus fraction, ln of 20 over ln of 7. 7? Yeah, 7. Right? That will be equal to 2.539. So I'll just put 2.5. So x would be approximately equal to 2.5. Now, I said that the answer would be the same, right? Now, the logs is going to be the exact same thing. So what I have to do now, just to prove that to you, because most people trust the calculator better than anybody else who doing calculations for them, just simply back up here, backspace, and take a log. Now, notice I have log 20 over log 7, which is what I would end up which is what I would have if I did this with logs. And when I press the equal sign, I get the same 2.53, and I can just go up and you can see the same answer that I'm going to get. right? So it doesn't matter if you do natural logs or logs, you're going to get the same answers for your question. So it's not going to be a problem for you, okay? Just remember the equivalence. Remember that log to the base of e is simply ln. All right, so that is that. That would be number 2. Let's do number 3. Let's do a third one. So example number 3 is to solve 1/3 to the power of x equal to 5. I'll say given 1/3 to the power of x equal to 5. Let's say that's 1. Taking logs both not a e sides, taking logs both sides, then we would be able to write this in a form with logs. So we can have log of 1/3 to the power of x equal log of 5, which is x log of 1/3 equal to log of 5, like that. And then I can say, I can, okay, no, I can just simply take this and divide it by this, and I'll get my answer for x. But I just want to be exaggerated a little bit, right? So if this looks too complicated for you, I just want to exaggerate a little bit and just use the laws. You don't need to. I'm just doing it for doing its sake. So using quotient law of logs, we can have this written as x into log of 1 minus log of 3, close bracket, equal to log of 5, and therefore x would be equal to log of 5 divided by log of 1 minus log of 3. And let's calculate that and see what we get. So log, fractional form, log of 5 over log of 1 minus log of 3, and we get an answer of negative 1.5, right, which is equal to negative 1.5. Okay, well, approximately equal to, right? And let's do another one. These are rather simple. I don't need to even do this many examples, but I just think that I should do it because the lesson seems a little bit too short if I just leave it right where it is. Solve 9 to the power of 2x plus 1 equal to 5. It looks difficult, but it's not. So given 9 to the power of 2x plus 1 equal to 5, and this here is 1, then taking, I'll use natural logs this time, natural logs, 1 becomes ln of 9 to the power of 2x plus 1 equal to ln 5, and that's going to be 2x plus 1 in a bracket, ln of 9 equal to ln of 5, and then that's going to be what? 2x plus 1 equal to ln of 5 over ln of 9, and then minus 1 from both sides, so that's 2x is equal to ln of 5 over ln of 9 minus 1, and then half of both sides, so x would be equal to a half into ln of 5 over ln of 9 minus 1, close the bracket. And that there would be able to give me the answer. Let's see what answer we get. So we have 1/2 in a bracket, and then I have another fraction which is ln of 5 divided by ln of 9, and then I'm minusing 1, and then I'm closing a bracket, an equal sign, and it's negative 0.1, right? So x is approximately equal to negative 0.1, right? And maybe I should do one more, and that's it. Let me give you a really complicated looking one also. Example number 5 that we can do, we can solve 4 to the power of x plus 4x minus 2 equal to 10. How does that look? Really complicated, right? So given 4 to the power of x plus 4 to the power of x minus 2 equal to 10, and then we have 1. So we're going to rewrite 4 to the power of x plus 4 to the power of x over 4 to the power of 2 equal to 10, right? So this is just using one of the indices laws that we learned about, and we're writing it. Now I can factor out that 4 to the power of x. So 4 to the power of x is going to be 1 plus 1 over 4 squared. 4 squared is 16, so that's 1 over 16. And this is 1, so that's 16 over 16. So I can write it as 16 over 16, and I can put this one here and rewrite this over 1 over 16. So that'll be 17 over 16 equal to 10. So I'm going to have 4 to the power of x is equal to, I'm going to multiply both sides by 16 over 17 to get rid of that. So it's going to be 160 over 17. And now I have it in the same form that everybody had it done before. So I can just say taking logs both sides, and we're going to get log log 4 to the power of x equal to log 160 over 17. And then, oopsie, more page. Right, where we reach. So there, and what we need to do now is we need to, well, I don't have to, or I can. So I'm going to separate this, and I'm going to bring this power down, and then I'm going to do the division by the 4 log. So I'm just going to write it out. So let's see, x log of 4 is going to be equal to log of 160 minus log of 17. I didn't need to do that, but I just did it anyway. Then x will be equal to log of 160 minus log of 17 all over log of 4, right? And with that, we can get an answer for x, an approximate value for x. Let me just work that out right now. So we can have here a fraction where we take the log of 160 minus the log of 17 and then divide that by the log of 4. And we get 1.6. Right? So x is approximately equal to 1.6. Right? So that is it. That's all you had to learn when it comes to solving some equations in that exponential form. Instead of using this equivalence right here, you can just simply, as I did there, take logs both sides and just simply use your algebra knowledge and solve. Right? If you have any questions, comments, or you see any issues that you would like me to address, let me know. I would see you in the next lesson. Enjoy the rest of your evening. Goodbye.